Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Asia Atira binti Abdul Rahim. My metric number is DE220046 and I will present about introduction. In multivariable calculus, triple integral extend the concept of integration to three dimensions, allowing the calculation of volume, masses and other quantities over a 3D space. To find the volume of the region below z equal to 4 minus xy and above the xy plane within 0 less than equal to x less than equal to 2 and 0 less than equal to y less than equal to 1, we use a triple integral with appropriately defined limit and evaluate it in Cartesian coordinate. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Daniel Memang Hamdan. I'm from Faculty in Electrical and Electronic Engineering. My matrix number is DE220039. So today I will present about the methodology. So firstly, concept mapping about the multiple integral have two elements. Number one is a double integral and secondly is a triple integral. So firstly, this topic we need to discuss about the triple integral. So the triple integral, we measure the volume. So the formula is a 3 integral and dv. So triple integral have three elements. Number one is a three-dimensional Cartesian. Three-dimensional Cartesian, we need to measure the coordinate system x, y, and z. Secondly is a cylindrical coordinate. The formula is a radian, theta, and z. Lastly is a spherical coordinate. The formula about the spherical coordinate is a rho, phi, and theta. So all the element we need to finding the volume for the 4 lamina and 4 solid. So this is finding the mass, moment, center of mass or central moment about the inertia. Alright, so we need to continue. At this point in this chapter, we discuss about chapter of multiple integral, part of triple integral. Triple integral have a three elements such as three-dimensional Cartesian, cylinder, and spherical. Instead of a small interval or a small rectangle, there is a small rectangle and there is a small box. Instead of length, dx or area, dx dy, and the box volume dv equal to dx dy and dz. That is length time width time height. The goal is to put small boxes together by integration. The main problem will be to discover the correct unit limits on x, y, z. We could dream up more and more complicated region in three-dimensional space, but we don't think can see the method clearly without seeing the region clearly. In practice, six shapes are the most important. So this is a example for the question triple integral. So the formula this have a three integral. So the three integral is a box dv. So dv we refer to the description above. Dv equal to dx dy dz. Alright, so what is a dx dy dz? Okay, so how to calculate the box? We can to imagine the cube. So the cube, what is the formula to cube? To measure the volume. So the formula of cube is a length multiple to width and multiple to height. Right, so because the cube have a six surface for the measure the volume. So refer to the dx, dy, and dz. So what is how to write the value of dx, dy, dz. So dx we need to measure the value. Dy we need to measure the equation, and lastly dz we need to measure the volume. Okay, so this is example about the question for the triple integral. Alright, so after this, you need to calculate to get the answer for the volume of a box. Okay, and next, we need to measure the value for the triple integral. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Kumasha bin Nasir. My metric number DE220024. Now I will present about the manual calculation, which is triple integration. For the first integration, we integrate with respect to z, and then integrate with respect to y, and lastly, we integrate with respect to x. For the limit of integration for x is 0 to 2, and the limit for integration of y is 0 to 1, and the limit for integration dx is 0 to 4 minus xy. For the first integration, which is integrate with respect to z, the value we get is 4 minus xy. And then the second integration, which is for integrate with respect to y, the value we get is 4 minus 1 over 2x. And lastly, the integration of x, the value we get is 7 unit cube. That's all from me. Thank you.
Hi, a very good evening. My name is Nathan Anthony. My matrix number is DE220068. So I'll be presenting the simulation and coding part. So well, if you can see, this is our coding. So we have used the MATLAB software. So for the coding, first we have insert the equation as it was in the question. Then I've written the command for the specific integration limits. Then I wrote the command to calculate the integral using the integration function. Later, I used the display command to display our answer. So, well, if you can see, this is our answer. The volume of the region is approximately 7, which is similar to the manual calculation, which is proven. Next, I'll show you the graph. So now as you can see, this is our 3D graph and this is the simulation code. So in the simulation code, we have used the equation to build the 3D graph, and we have insert the grid of x and y values. Then we have computed the corresponding values. Later we have insert the 3D graph surface plots. Then we have used the rotate view for better visualization, and this is our output for the 3D surface graph. So for a better view, you can turn to the next slide to have a clear view. Thank you very much.
So, and lastly, for the conclusion, and finally, my name is Muhammad Zikri Zubair, and I'm going to talk about the conclusion. To find the volume of the region below z equals to 4 minus xy and above the xy plane within the numbers, and we use the triple integral in Cartesian coordinates by integrating the f bracket xyz closing bracket equals to 1 over this region within x from 0 to 2, while from 0 to 1, and the z is from 0 to 4 minus xy. We can compute the volume, which is, and this highlights the utility of the triple integrals in calculating volumes for three-dimensional regions in multivariable calculus. So I think that's it from us, and thank you.